All right, so now that we understand metals and nonmetals and basic properties on the periodic table, we need to consider how that affects how bonds are made. We're going to look at making ions and ionic bonding, and then we're going to look at molecules and covalent bonding. So let's start to make sure we understand what we're talking about in terms of ions. An ion, by definition here, is something where the number of protons are not equal to the number of electrons. It has a net charge. So please remember that each proton, one proton has a charge of +1, one electron has a charge of -1. So if we look at sodium, sodium, by the way, has 11 protons. If it's neutral, it's going to have 11 electrons. So if we have 11 protons and 11 electrons, that's going to be +11, -11 for a net charge of 0. Now, sodium is a metal. We know this because it's on the far left of the periodic table. If it's a metal, when metals react, they lose electrons. So again, metals lose electrons. In the case of sodium, it's going to lose 1 electron. Now, when it loses 1 electron, it's now going to have 11 protons for a charge of +11. It's going to have 10 electrons. It's lost 1. And if it's got 10 electrons, it's now going to have a charge from the electrons of -10, and it's going to give a charge of +1 left over. This makes it an ion. Protons are not equal to electrons. It's positive, so this is a cation. Cation means it's got a nice positive charge. So remember, an ion has a net charge as an even number of protons, electrons. Cations have positive charges, which occurs when a neutral atom loses an electron. Remember that metals lose electrons and make cations. Anions are ions with a negative charge. This is what happens when something gains an electron. Nonmetals gain electrons to make anions. So for example, if we have chlorine, chlorine is neutral such that it has 17 protons and 17 electrons. Chlorine is a nonmetal, so it's going to gain electrons. In this case, it gains 1 electron. And when it does, it's going to have 17 protons and 18 electrons. Because electrons are negative, this is going to give it a net charge of -1. If we looked at this in terms of our isotopes, now this is the last time we're going to look at an actual individual atom. Atoms are too small to measure and deal with in chemistry, so we're going to deal with bigger numbers than that. So our last shot on isotopes. If we have helium, for example, and we want to write the symbol here of a ion that is also an isotope, we're going to put the mass number. This happens to be the isotope of helium with 2 neutrons. This happens to be the ion of helium that's lost 2 electrons. So if we take helium, such that we have helium-4, and we lose 2 electrons, it's going to make the helium cation. It's going to look like He4. That's a mass number. The atomic number down here is often omitted because we know helium is 2. Why? Because we've got a periodic table. Magnesium, if I look at the isotope of magnesium such that it has 12 protons and 12 neutrons, making it magnesium-24. If it takes and it has lost 2 electrons, it's going to have a charge of +2, and we write the +2 here, the charge, as a subscript to the right-hand side of the symbol for the element. So if we have these two right here, so let's make sure we understand our ions. If we have aluminum 3+, so aluminum 3+, well, we know that aluminum has 13 protons. It should have had 13 electrons, but because it has 3 more protons than it does electrons, this gives it 10 electrons. Make sure that makes sense. Plus 13 minus 10 gives us +3 left over. If I want to know how many neutrons it has, I take 27 and subtract 13, and I will get 14 neutrons. Now, if I want to look at selenium 2-, selenium here has a atomic number of 34, which means it's got 34 protons. It's got a charge of 2-, which means it has gained 2 electrons. So if it started out with 34 protons and 34 electrons, and now it has 2 electrons left over, it has added 2. So therefore, we have 36 electrons, we have 34 protons, and if you want to know how many neutrons it has, remember the 38 minus 30, or excuse me, 78 minus 34 is going to give you the number of neutrons. All right, so let's complete this table. If we have an atomic number of 16, well, if we have an atomic number of 16, we look at our periodic table and realize that that's sulfur. We know the atomic number is the same as the number of protons, so that's 16. If we have more electrons, we know our charge is negative. We have 2 more electrons, so that's 2 minus, and that is our charge. If we have 12 protons and a charge of 2 plus, it tells us that we have 2 less electrons than protons, which tells us that we have 10 electrons. Our number of protons is the same as our atomic number, which is 12. If we look at 12, that is magnesium, and we put the charge right up here. Our aluminum, if our charge is 3 plus, we go back to aluminum and realize the number of protons is 13 and the atomic number is 13. If we have 13 protons and a charge of 3 plus, it means we have 3 less electrons, so we're going to have 10 electrons. Now, 36 electrons with a minus 1. If we have 36 electrons and a minus 1, it tells us we have 1 more electron than we have proton, because electrons, again, are negative, and we've got 1 extra. So we have element 35 with 35 protons. Off of our periodic table, we've realized this is bromine, and we take the charge, which is minus 1, and put as a minus. The 1 is implied, and we don't use it when we add a minus 1 or a plus 1 on our charge for our ion. All right, so chemical bonds. Molecules or compounds are chemically bonded such that they have no charge. We can do this one of 2 ways. We can either make covalent or ionic. If we make covalent, our electrons are shared. If we have ionic, our electrons have been transferred. And after they have been transferred, we have made ions, and our compounds are held together because opposites attract. Such that if we have something positive, something negative is going to stick to it. So we have 2 options. Electrons are shared, and when they're shared, we come in and make a covalent bond, or we have positive and negative things sticking together, and that makes a nice ionic bond. It's fairly easy to spot which one you're going to make. Ionic bonds are made between a metal and a nonmetal. Why? Because metals lose and nonmetals gain. When metals lose, they make cations. When nonmetals gain, they make anions, and they stick together. Covalent bonds, on the other hand, are made when electrons are shared. This is made between stuff that needs or wants electrons, which means it's going to be made of nonmetals. All right. So, covalent bond. Covalent bond is going to involve 2 or more nonmetals. You're going to result in something like a molecule, and this could be something like H2O or CO2 or something complicated like glucose. It can be 1 set of electrons shared or 2 or 3 or all sorts of different options. This is going to be chapter 7 and 8. And aside from noticing that it is made up of nonmetals, and we will name some very, very simple ones as we go through this chapter, we just need to recognize that nonmetals will share electrons and make a covalent bond. For example, covalent compounds would be these. And when we look at our naming, as we go further on in this chapter, we're going to name simple binary, meaning made up of 2 different elements bonded together. Covalent, they're going to be nonmetals. Complicated naming of these or naming of complicated ones we leave for organic chemistry. All right, an ionic bond. An ionic bond occurs between a cation, which is going to be a positively charged ion made when metals lose electrons, and there's going to be an attraction between it and an anion. An anion is made from nonmetals. Nonmetals are going to gain electrons, and this positive is going to stick to this negative. Now, when we take and we write the formula for an ionic compound, for example, NaCl, We write it together such that we ignore the charges. It is in fact a attraction between an Na plus and a Cl minus. Now, when we write this, this is going to be the simplest ratio of ions in this compound. Ionic compounds are actually massive three-dimensional compounds because if we put the sodium in the chloride, this is negative and something positive can come in and stick to it. And something positive could come in and stick here, and something negative could come in and stick here. And these keep alternating such that at the end we write the simplest ratio, which in this case is going to be something we deduce from the charges, and that is going to be 1-to-1 NaCl. So let's take a look and make sure we can recognize these. We need to know if it is a atomic element, a molecular element, remembering that is two or more atoms of the same element, a molecular compound. And when we say molecular compound, that means covalent. And now we're going to separate molecular from ionic, where ionic is going to be made from ions. And we're going to spot that because without pretty much with only one single exception, that is going to be made from a metal, the nonmetal. So with that in mind, we can go through this. Aluminum, one substance, therefore it's an element. Aluminum chloride, well, aluminum is a metal, chloride is a nonmetal, so this is going to be ionic. Cl2, well, Cl2 is one element, one substance, but there is more than one atom of it. Therefore, this is a molecular element. Acetone, C3H6O, well, we have to look at the periodic table. And when we look at the periodic table, we discover all of these are on the right-hand side, and then these are going to be nonmetals. And because they're nonmetals, this is going to be a molecular compound, meaning it's going to be covalently bonded. CO is the same thing. It's made up of nonmetals. Capital C with a lowercase o is a whole different thing. That happens to be a metal, one thing by itself, therefore it is an atomic element. And you can go through back to this in aluminum and call this an atomic element as well. In general, we just tend to call atomic elements just elements.